Yeah, hello everyone, and we are testing our sound as usual. Let's see if you can see and hear us.
Testing, 1, 2, 3.
Yep, looks like everything is working fine. Let me start the session. Hello everyone, I am Bogdan Maherus, and today we have the other session of the data community United for Ukraine. And as you know, in September we had our sessions that were created to fundraise for the Ukrainian army. And as you know, now in Ukraine, we have a war started by Russia, and we are doing the fundraising events by data community United for Ukraine. And today we have many people. We have Murilo Miranda, Catalin, Giorgio, Diane Sarka, Andrea Melancia, and Bill Inmon. Thank you everyone for coming today. And our amazing speaker today is Bill Inmon, the father of the data warehouse. And today we are going to talk about data lake house. So Bill, thank you for coming today. Thank you for finding time to join us, to support us. And such support is very helpful for Ukrainian defenders, for us Ukrainians who are fighting for our independence today. For everyone, don't forget that the purpose of the conference is fundraising money for the Ukrainian army, and in the description of the video, you can see the link where you can donate, and all donations are going to fundraise money for the drone that is needed for Ukrainian army. So thank you, everyone. Bill, your turn. What are we going to talk today about?
Thank you, Bodan. It's my pleasure to be here, my honor to be here, and I hope to support Ukraine as best that I can. I want to talk with you today about my favorite topic on earth, data architecture and the evolution that we've seen. Many years ago, we started with something called data warehouse, and today we have evolved into something a bit larger, a bit more complex, called the data lake or data lakehouse. So I want to give you some thoughts. I'm going to try to share my screen with you. And if I have done it correctly, you should be seeing a blue screen. Is that what you see?
Correct.
Okay. I want to talk today then about data lakes and data lakehouse because there's a lot of interesting things that are going on. I want to begin with all of the data in the corporation. This orange bar is an indication of everything that is data in the corporation. And what we find is that the general categories of data in the corporation are structured data, textual data, and analog IoT data. So we find that when we look at these different types of data, they have very different characteristics. They have some similarities, but mostly they have differences. It is like the Earth. On the Earth, we have Antarctica, we have the Sahara Desert, and we have the Amazon jungle. And all of these are parts of Earth, but these places are very, very different. And if you were to travel to these places, you would wear clothing and be prepared for very different experiences. And that's the kind of differences that we find in the types of data that we're looking at. So let's now discuss the different types of data. The first type of data that people experience is something that we call structured data. It's usually transaction-based. We can think of bank transactions, point of sale transactions, telephone calls, payments made, payments received. And typically, structured data is organized into records, keys, attributes, and indexes. And it's the kind of data that most people are familiar with in their career and in their everyday working life. The reason it's called structured data is that each record is structured the same as any other record. The contents are different from record to record, but the structure of the data is the same. So if I go into a bank and make a transaction, my transaction is going to look exactly like your transaction. From a structure standpoint, the difference is going to be my information is going to be in one record and your information is going to be in another record. Now let's go to the second kind of data, textual data. Textual data is found everywhere. Where do we find textual data? We find it in medical records, contracts, internet, call centers, etc., and so forth. There's a lot of reasons why textual data does not appear on the computer on a frequent basis. For one thing, textual data is found in different languages: English, Spanish, Portuguese, Russian, etc. The second thing, textual data contains different types of text. We have formal language, we have slang, we have acronyms, and so forth. A third factor that is makes text hard to deal with is that text occurs in lots of different forms. It can occur as voice in a conversation between people. It can be written as on a book. It can be on an internet. It can be on a video. These are just some of the challenges of textual data and some of the reasons why textual data has not been automated to any great degree. Today, there is technology that allows textual data to be put into a structured form. And in doing so, we can start to do analytical processing on textual data. And that technology, you may not have heard about it, is called something called textual ETL. The third kind of data is machine-generated data. This is data that's generated by a machine. And we find that there's many kinds of machine-generated data in the world. There are drones, electric eyes, temperature gauges, speed equipment, mechanical equipment, telemetry, and so forth. And there's all kinds of machines that are out there generating data. I don't know if you know it, but in today's world, the modern watch that you wear on your wrist and the car that you drive are all the time generating data. In order to understand the properties of analog data or machine-generated data, think of a surveillance camera. Suppose that you have a surveillance camera looking at a parking lot. And so this surveillance camera looks at the parking lot 24 hours a day. And the vast majority of the images taken by the surveillance camera are very unimportant. There's sometimes the lot is empty. Sometimes people are driving a car into the lot or taking a car out, and it's very unremarkable. However, every now and then, there's an accident in the parking lot, or there's a robbery or break-in in the parking lot. So what you find with machine-generated data, such as a surveillance camera, is you find that a small percentage of the data is really useful, and a large percentage of the data is not useful at all. So what people have told us is that we should take all of these kinds of data and put them into the data lake. And once the data is in the form of a data lake, we can then do analytical processing against it. And what we find is when we do that, soon the data lake turns into a swamp or a sewer. We find out that the data lake actually doesn't do us any good at all. And so why is it then that the data lake turns into a data swamp, or a data sewer? Well, there's a lot of reasons why the data swamp is being derived from a data lake. And let's examine those reasons. In order to make the data lake useful, we need to transform the data lake into something called a data lake house. That's what we need to do if we're going to have a valid use of the information in the data lake. Now, who is this important to? This notion of value of data in the data lake is important to a lot of people. But one of the communities that the data lake is important to is somebody called the data scientist. I don't know if you've talked with many data scientists, but here's what conversation I've had on many occasions. The data scientist goes to school, learns all about statistics, learns all of these wonderful techniques. Then when they go into the world, 95% of the job of the data scientist is dealing with the data, not doing data science. And what happens is the data scientist turns into a garbage man when you have the data lake and the data scientist put together. What we need in order to make the data scientist an effective person is an infrastructure. We need an infrastructure that allows the data lake to be useful in the corporation. And this infrastructure, when we add it, is what we call the data lake house. So in order to understand this, I want you to consider something else. I want you to think about a library. When you go into a library and you're looking for a book, do you start to go through all of the different stacks of the book? Is that what you do? And the answer is you're going to be in the library a long time because you may never find the book you're looking for. In order to be useful to go into a library, what you need is a card catalog. So you walk into the library, you don't start to look through all of the stacks of the library. You start to look into the card catalog. And it's very easy and efficient to look through the card catalog. Once you've found the book that you are looking for in the card catalog, you know where in the library to go look for it. So what we need in order to make our data scientist a productive person is a card catalog for our data lake. So once we have the card catalog for our data scientist, we now are in a position to start to make data science a reality. And so that's how we go from a data lake to a data lake house. So what does this card catalog look like? Well, it's actually a complex thing. There's a lot of elements to the card catalog. There's such things as metadata that most people are familiar with. Metadata tells us where the attributes of our data are, our keys, our indexes, and things like that. And most people understand metadata. But when it comes to handling text, we have some other things that we haven't probably seen much of. We have things called taxonomies and ontologies. And a taxonomy or ontology is similar to metadata and yet different from it. Then when we go to our machine-generated data, we have something called distillation. And so we find then that as we go to create one of these card catalogs to make our data lake useful, that there's a lot of elements, each of which are necessary in order to make the data lake turn it into a data lake house. So that's the problem that organizations face today. They simply can't just throw data into the data lake. They've got to create the analytical infrastructure as well. So how does data get into the data lake? Let's examine that. When it comes to transaction-based data, we have to transform the data from a transaction format through something called ETL, extract, transform, and load, to put it into the data lake. If the data is going to be useful in the data lake, it's got to be transformed. We can't just throw a bunch of data in there. Now, it turns out that if all we were doing was putting transaction data into a data lake through ETL, that in this case, the data lake would look exactly like a data warehouse. But that's not what we're doing today. Today, we're adding other kinds of data in, such as text. And so we find then that with text, there's technology called textual ETL that allows us to take the text, put the text into the data lake. So just like transaction data needing ETL, textual data needs textual ETL in order to be put into our data lake to turn it into a data lake house. Then we have distillation and refinement of mechanical generated data. And to do that, we have a distillation and refinement process. You see, if we take all of this data generated by a machine and put it into the data lake, we will overwhelm the resources of our computer and be putting huge amounts of data that doesn't mean anything into our data lake. And that greatly, pardon me, that greatly inhibits the type of processing that we can do. So let's talk very briefly now about textual ETL. Textual ETL makes use of three things in order to put data into the data lake. You start with the raw text, and that can come from many, many sources. You do something called inline contextualization, and you make use of taxonomies and ontologies. And this is what it takes to take text and turn it into a useful form in the data lake. Now let's talk about the distillation process for analog data. We need to understand what we're doing here. What we're doing here is only putting the data that has a high probability of access in our data lake. The data that doesn't have a high probability of access, we're going to put into bulk storage to where we can still get to it, but it doesn't get in the way of analytic processing. So we want to go into our basic raw measurements, find which measurements, if this were the parking lot that we talked about with the surveillance camera, we don't want to put all of the images taken on the surveillance camera because that's going to confuse things. We only want to put the instances when there's been an accident in the parking lot or when there has been a break-in or robbery in the parking lot. That's what we want to put into our high probability data lake environment itself. So we see then that we need to separate, and this separation is called distillation. We need to distill our environment as we put it into our data lake. Now, there are a couple of things from a data architecture standpoint that may not be obvious, and I want to make them obvious to you. Number one is the relative volumes of data in each sector, that relatively speaking, there's relatively little structured data in the world. There's a lot more textual data in the world, and the biggest amount of data is the analog mechanically generated data. And so these relative volumes of data are what we come to expect in the corporation. And what we find is that when we divide these worlds up into do they have business value or do they have no business value? What we find is that nearly all of structured data has business value. Some of textual data has business value, and very little of your analog mechanically generated data has business value. So what we want to do is to put the data that has great business value into our data lake where it can be analyzed. We want to put the other data that we have into something called bulk storage. So now when people have said, gee, Bill, when you put your data into bulk storage, does that mean you can't analyze it? No, you can always go into bulk storage and analyze it. Now, I'm going to tell you, analyzing data in bulk storage is not a particularly easy or efficient thing to do, but it can be analyzed. It can be looked at and analyzed. So it's not like you're making a decision as to what data you need to look at, because you can always go back to bulk storage and look at your data. Furthermore, as data ages and needs to be archived, it needs to be put from your high performance data lake environment into an archival environment of bulk storage. You don't just put data into the data lake and leave it there forever. So when we do this, we find that the data in high performance storage is fresh, available, accessible. Somebody knows what it means. And now we can start to have our data scientists do a good job for us. So one of the questions that people typically ask is the data warehouse the same thing as a data lakehouse? And indeed, there are certain similarities between a data lake and a data warehouse. But let me give you an analogy that I hope explains it. Suppose you have two cousins sitting in a room, two young children that are 5 or 6 years old. One is a girl, one is a boy, and they happen to be cousins. When you look at them, you find that they have very similar features. Their facial features are the same, the color of their hair is the same, the color of their skin is the same. It's very obvious that they are related to each other. But are they the same thing at all? No, genetically they are different. One of the cousins is a girl, the other cousin is a boy. So if you were to look into the DNA of the two children, you would find that yes, there are very definitely similarities. At the same time, there are very definitely things that are not the same. And so that's the answer that I give people. Is a data warehouse the same thing as a data lakehouse? They are related, but there are some definite dissimilarities between them as well. So I hope that answers that question, because that question arises all the time. So now with analytics in the data warehouse, you can improve the lives and livelihood of many people. And this is something that is liberating to corporations, governments, countries around the world. We've talked today about textual analytics and textual ETL. I'd like to call to your attention that there's something that you can get for free. You don't have to pay anything for it. It's in English, but there is a book on the simplification of textual analytics, and that's what textual ETL is. Textual ETL, you can get it by going to the website listed below, forestrimtech.com. Look for ebook, and then tell us where to send the book to. So in case you're interested in textual ETL, this will tell you all about it. Okay, we have some time for questions. I'm more than happy to spend some time with you answering questions.
So at this moment, I don't think we have any questions yet, but we can check if anyone in the next few seconds will add some questions.
Okay.
Okay. In the meantime, maybe we can ask a few questions. So both me and other speakers from previous sessions, we can also ask them some questions. Let me ask you a very provocative question, if that's okay.
Sure.
So one of the things that you are famous for is data warehouse, a top-bottom approach. What is your opinion of current systems these days? Would you change something to the current systems? Do you feel that these are appropriate? What's your opinion on the current situation of things anyway?
Data warehouses are as necessary today as they were 20 years ago. Nothing has changed with regard to that. What has changed is the type of data that we're operating on and the expansion of the types of data that we have. So data warehouse was written and built for structured data. It was not built for textual data. It was not built for analog data. And so that's what's changed today. But is there a need for a data warehouse? Let me tell you why there's a need for data warehouse. Corporations around the world have a hard time answering some simple questions. The larger the corporation, the more difficult it is, such as who is a customer? What is a product? How much money did we make this quarter? Those questions in the face of a large corporation are difficult questions to answer. And you can't answer those questions unless you have a data warehouse. So that's why you need a data warehouse today.
Okay, thank you very much for your answer. We do now have some questions. So Thomas is asking, first of all, he's thanking you for the presentation, and then he has a question. So if you could please clarify, because nowadays we have so many terms, etc. So he asks you to please clarify the difference between having a data warehouse plus a data lake versus just a data lake house. So nowadays, I know that there's a lot of different terms, like database, data lakehouse, lake store, etc. There's so many terms nowadays. I think it gets confusing for everyone.
Vendors invent these terms to confuse people, and I don't mean to be cynical about it, but it's the truth. Vendors invent these terms to confuse people. And when the data lake came out, I'll be honest with you, I was horrified, because the data lake by itself is a very, very bad idea, because a data lake turns into a sewer, because nobody can use it, nobody wants to use it, nobody can find anything, and so forth. So what you have then is the need for this analytical infrastructure. And by the way, the analytical infrastructure is not easy to build. Anybody that thinks it's easy to build hasn't done it. And the analytical infrastructure is something that is absolutely necessary, but not easy to build. So when it comes to the difference between a data lakehouse and a data warehouse, okay, if all you were looking at is structured data, then you don't need a data lakehouse. You need a data warehouse. But the minute you start to include other kinds of data into the environment, then's when a data warehouse morphs into a data lakehouse. I hope that answers the question.
Thank you very much. So we have a few more questions. We have a question here from Hubert. And this is related to the presentation specifically. Are those layers a good practice to organize data by maturity and fit to purpose?
I'm sorry, I don't understand the question, so it's going to be hard for me to answer it.
So okay, maybe we can come back to this and get some clarification. Okay, let's ask a different question. So this is also a question that I've had over the years, and a lot of people seem to have. So is data mart a third cousin? So I think that the question is, what is the difference between data warehouse, a data mart, etc. So obviously this is a very basic question, but it's still a question everyone asks, because when they get started with data warehousing, this is still a confusing topic.
The difference between a data warehouse and a data mart. A data mart does not require that the data be integrated, whereas a data warehouse does require that the data be integrated. And over, people have found that it's very quick. And by the way, I have never told anybody in my life that it was easy and quick to build a data warehouse. Not once ever have I ever said, oh yeah, you just build a data warehouse, because I know that it doesn't happen that way. I know that the integration of data, the cleansing of data is not something that is easy to do. I know that. Data marts, on the other hand, are very easy to do. You can build a data mart from 1 or 2 applications and you can build it quickly, but your data isn't integrated. And so what people have found is that building the data warehouse and then building data marts from the data warehouse is an actually architecturally very good solution. So data marts by themselves are not a good solution. A data warehouse is not easy to build, but when you combine a data warehouse and a data mart together, you get a very, very solid solution.
Thank you, sir. I do have an interesting practical question here from Oleg. What is the best strategy for Lakehouse partitioning? And not an easy answer, I suppose.
I'm not sure. I have to tell you, I've never been asked that question before. And I congratulate the person asking it, because that doesn't happen very often. I hate to tell you this. I would have to think about an answer for that. And in today's meeting, we don't have time. Let me think about it, and I will try to send you a written answer for it. I can tell you that mixing analog data, textual data, and structured data is very difficult to do. So partitioning that data off is one thing you've got to do. The other thing you've got to do, regardless of the kind of data that you have, you've got to have an archival strategy. That so many people think that they're going to put data into a database and that's all there is to it. And they wake up one day and find out there's all kinds of older data in their database that doesn't belong there. So two of the elements of partitioning the data are, number one, the type of data, and number two, the age of the data. But I strongly suspect that there are other criteria on which you want to partition your data. However, I've been doing this for a while, and I've never been asked that question, and I would have to think about it to give you a more reasonable answer.
Okay, so we have an additional question from Andrea, and the question is if the data that you store in a Lakehouse, whatever the marketing name you're going to use for that, if they can be used as structured data as if they were real tables. I know the answer is yes, but would you like to elaborate on the question?
Yes, yes, of course, you can use the data in the Lakehouse. The problem is, okay, the problem is if you're thinking about real-time online processing, data in the data lake is very difficult to use for that purpose. The real value of the data lake is to use the data for analytical processing, which is different from transaction high performance processing.
Perfect. Okay, so we actually have another question from Oleg that asked you about partitioning. And the question is also very practical, so very interesting questions. How do you suggest compressing or not compressing the files in the Lakehouse?
Oleg keeps asking questions that I've never been asked before. Generally, you don't. Generally speaking, the technology of today, things like Hadoop, things like big data, things like that, give you the freedom to not compress the data. Now, when it comes to text, that's a different story. With text, you can take the text, put it into the form of a database, and that greatly compresses the data itself. But when it comes to structured, in the case of structured data, you probably don't want to compress structured data. When it comes to textual data, you probably want to turn it into a database. When it comes to analog data, you definitely want to distill the data.
Okay, and we have a question from Hubert, and this is an interesting one because in some cases these terms might be considered also marketing terms. So if you go for things like Databricks, they suggest a Delta Lake architecture where you have ETL layers like bronze, silver, gold, etc. What's your opinion on these kind of structuring? For the ETL process in this case?
From the standpoint of Databricks, I have nothing but good things to say about Databricks. And so I agree with their different levels of structuring. It does match well with the notions that we have of the data lakehouse. It goes back to that business value versus non-business value. The greater the business value of data, the more it belongs at the gold level, the less value business data has, it belongs at the lower levels.
Okay, so we also have quite a few questions, as far as I can see, with some more terms. So before we had some questions about some terms, and we have Thomas and a different Oleg. Let me mention. I'm not using last names deliberately, and also Christina asking about things like data mesh, comparing to data lake concepts and also data hubs as well. So what's your take on all of these new terms and all of these new I would say functionalities, but methods, functionalities? I'm not sure how to qualify all of these together.
I feel a bit uncomfortable answering this question because a lot of the terms that you see out there are inventions by the vendor to sell what they have, and they don't mean anything. I will say this much, that all of those terms, if you don't put data mesh, if you don't put machine learning, if you don't put artificial intelligence on a foundation of solid data, you get the most simple, basic question in computation, and that's GIGO, garbage in, garbage out, and so the vendors of AI, machine learning, data mesh, or whatever, seem to have not learned that they need to be operating on a foundation of solid data. because you can have the most wonderful AI, the most wonderful data mesh and whatever, but if the data you're operating on is not solid and has integrity, then you're not going to have success with AI, data mesh, or machine learning.
Okay, literally on that subject, we actually have Alexei asking questions concerning the data lake of analog data. Is there any automatized way with proven efficiency for accurately recognizing the useless data? So anything that you want to clean up, so separating them from the useful data and cleansing useless data. Is that process already reliable and safe?
That is at the forefront of technology today. We are just learning how to do that. Let me share some new examples. The hard way to do it is the way the police do it. Suppose you've got a surveillance camera that sits there and looks at hour upon hour of a parking lot, and the police want to find out what's going on. The way the police do it is to sit there and look at the tape for hour after hour, and that's crude, that's inefficient, but that's how it's done. And this is a whole other large topic, and I hate to say it, but in today's conversation, we just don't have time to go into it. So now I would let me call your attention to there was a book that was released just about a week ago called Data Lakehouse Architecture. You can find it on Amazon.com, and it goes into that subject in a great deal of depth. But that's the most interesting subject, I might add. And let me tell you, the way not to do it is the way the police do it. Because can you imagine the person that has to sit there and their eyeballs will bleed by having to look at the same thing hour upon hour. And then furthermore, when the robbery in the parking lot occurs, they may miss it. And so that's how not to do it.
Okay, so we are almost running out of questions. I can see that Damien, which is one of our previous speakers, is asking a question, which is, what is the future of data warehousing and business intelligence and literally everything that we can do with data warehouses in the future?
The great value that data warehouse gives is it gives the corporation or government the ability to answer simple questions. How many customers do we have? How many products do we have? Et cetera, and so forth. And so as long as we have the need for that kind of information, which is like for the future, as long as we have that, we're going to be needing data warehouse.
Okay, so we have two questions. I'm going to ask the last question first from Dmitro. So what solution is good and easy for use to build a data warehouse? SQL Server, AWS, Redshift, some other solutions? Difficult question.
Each of these technologies have their strengths and weaknesses, and I am completely neutral to vendors. I don't work for any of the vendors. So I really don't want to answer that question.
Completely understood. Okay, we have one more question from Eugene. This is a very personal question.
Okay.
So interesting but personal. Those are always the most interesting ones. So, what was your biggest mistake in your professional career you've learned from in the past? The one that significantly changed your worldview. Interesting question from Eugene.
And first off, I could write a book about this subject, but when I started off my career, I believed that the business that I worked for was going to respond to and reward hard work and innovation. And it took me a long time to learn that was not the case at all. The reward of hard work and innovation is more hard work and innovation. And 3 times my boss got promoted for work that I had done. That's when I quit the corporation and went out and started to work on my own. So that was the hardest lesson that I learned.
Okay, thank you very much. I'm not sure if anyone else has any questions. I do have a lot of comments, so a lot of thank you messages from everyone, from Oleg, from Andrea, from other people as well in all of the streams that we are monitoring. I'm not sure if any of the previous speakers which are here in the session as well would like to ask some questions. A lot of questions already.
We had a no, and good questions, by the way.
Yeah, I guess.
I hate to tell you this, but I've got another presentation I've got to make in 5 minutes time. So I hate to tell you this, I've got to tell you goodbye.
Okay, thank you very much, sir. This was an amazing presentation, and it was really good to have you with us, and especially in this initiative, which is Data Community United for Ukraine and for this good cause. So thank you very much, and we hope to see you in future opportunities soon as well.
Thank you.
Yeah, thank you, Bill. Thank you for coming today. And such support is very helpful for us. So we're starting those session in September, and we continue them now. So we hope we are not going to stop, and hope to see everyone at our next sessions in December, and I hope during the next year. Thank you for your support. Be safe. See you very soon. Don't forget to donate.
Thank you, everyone, for being here. Thank you. See you next time.
Thank you.
Next week
Bye.
with Rezahat as well. Thank you very much.
Yes,
See you next
Rezahat about Power BI data marts. Thank you.